Alright, so here we are. Hello, good evening. I think this will probably be the last problem I do. Actually, no, I take that back. Let me see. I'll probably do a whole bunch more problems, but I'm going to keep my voice lower. I just want to, just give me a moment. I just want to set a timer. Yeah, actually, we have a pretty good amount of time left. So, let's take a look. We're going to take a look at the next question. I'm going to keep my, yeah, like I said, keep my voice low in order to not disturb anyone in the building. So, find the celebrity. Let's take a look. Let's take a look. Suppose you're at a party with n people labeled 0 to n-1, and among them there may exist one celebrity. The definition of a celebrity is that all the other n-1 people know him or her, but he does not know any of them. Liked. Immediately liked. That is so obnoxious. I don't know you. All of us, I mean, you all know me. Now you want to find out who the celebrity is or verify that there is not one. The only thing you're allowed to do is ask questions like, hi, A, do you know B? To get information about whether A knows B. You need to find out the celebrity or verify there is not one by asking as few questions as possible in the asymptotic sense. This is a fun question. Oh yes, asymptotic question asking. Those of you who are not super familiar with what that means, asymptotic time complexity, basically you deal with like infinite limits, so, or yeah, basically infinite limits, so it's as if you could ask someone infinitely, sort of, or ask an infinite number of questions. That's why it's kind of funny. It's the asymptotic sense, oh yes. Oh yes. You are given a helper function boolean knows AB, which tells you whether A knows B. Implement a function int find celebrity n. There will be exactly one celebrity if he or she is in the party. Return the celebrity's label if there is a celebrity in the party. If there is no celebrity, return -1. Interesting. Excuse me. The knows API is defined for you. Excuse me. So I want to find this as sufficiently as possible. Follow if the maximum number of allowed calls to the API is 3 times n. Could you find a solution without exceeding the maximum number of calls? Oh wow. Whoa, linear number. Actually, that's even stronger than linear. That's bounded by oh, that's a hard bound. Interesting. That's even harder. Graph length, n is the graph of I length. N is between 1, 2, and 100. Graph of ij is 0, 1. Graph of ii is equal to 1. So they always know themselves, certainly. Of course. But if you want to get extra philosophical, you would argue that, you know, who really does know themselves? There's so much to know. There's so much to know. 3 persons labeled 0, 1, and 2. ij equals 1 means person I knows person j, otherwise ij 0 equals they don't know each other. Equals 0, they don't know each other. The celebrity is the person labeled as 1, because both 0 and 2 know him, but 1 does not know anybody. Find out who the celebrity is or verify that there is not one. Okay. Well, let's think of a naive algorithm, right? A really simple brute force algorithm that would work. So you could take every point and then run this function, is A no B, round robin on every other point. And that's like a double for loop. That's what it would look like. When you do that, you'll find I guess you can count how many people. Oh no. That'll give you. Well, you can do a. Thinking there's a few ways to do this. Actually, when you do that round robin, how do you store the information and make use of it? Well, you want to figure out how many edges are incident on a node and how many edges are incident from and incident to, I guess, right? Because this is basically a directed graph. So you'd want to count those things for each node. So you can create two vectors of integers to do that, the outbound and inbound. So we could do that. Let's try that. See what that looks like. Right. Yeah. We don't care about the the loop back, whether or not it knows itself. Obviously, we were aware whether or not the node whether or not a node knows itself. So now I want to say if knows of ij, then outbound of I plus plus and inbound of j plus plus. Right. And now we just say for int I equals 0. If inbound of I equals n minus 1 and outbound of I is 0, and we found our celebrity. Something like this. Yeah, there we go. Okay. I think that's right. Oh, I did it. Okay, I was gonna double check if this is correct, but yeah, it's because there's n minus 1 other nodes, so it's got to be equal to n minus 1. Okay, so pretty straightforward. So that's like a brute force approach. How long did that take? It's been 10 minutes. Okay, that's like a brute force approach. Now, the tricky thing is we want to be more efficient than that, right? We want to be more efficient than that. So the thing is, we're trying to find that celebrity, right? There may or may not be one celebrity. There's 1 or 0. Everyone else know him, but he or she doesn't know any of them. Okay. So we gotta do, in order to find the celebrity, since everyone knows the celebrity, you can take one person and loop through everybody, and this person will, of all the people that the person knows, one of those, either there's no celebrity, or one of those is the celebrity. So now the tricky thing is, if the celebrity doesn't exist, the key of the celebrity is that everybody knows that person, and that person doesn't know anybody else. Now, let's pretend for a moment that we know the celebrity exists, and let's go from there. Let's pretend everybody knows the celebrity exists. Pretend that there is a celebrity. Check every node against one node, and you'll get a set of, you know, who this node knows. Here's another tricky thing. We don't have an adjacency matrix to work with. We only have this knows API, which is important because it means that it costs us quite a bit of computation just to figure out which nodes, which people know each other, which I guess is kind of the point to begin with. It's a very interesting question. Okay, so we start with, we pick a node, we say, okay, check all the nodes that this node knows, and this celebrity has to be one of those. Now, how do we eliminate the other nodes and only have the celebrity node? Well, For starters, you can also check, does that node know, right? Does that node know? Now, as you're checking, you can check A knows, you know, X, Y, and Z. Does X, Y, or Z know A? Of those nodes, one of them must not know. At least one. But there could be more than one, right? Oh, I got it. I got it. This one here. You check. A has a node that it knows, but that node doesn't know him. And B's got a node that it knows, but that node doesn't know him. So you find all of A, find all of B, you find this node that A knows and doesn't know him, B knows, doesn't know him. If there's only one such node, that's the celebrity. If there's none of those nodes, there's no celebrity, right? So you could figure out that there's no celebrity almost immediately, because you could loop through all the nodes for some A, and then all the nodes for some B, right? And obviously pick an A and a B that, you know, I guess they don't know each other, something like that. But yeah, all the nodes that A knows and that don't know A, and all the nodes that B knows that don't know B, there could be 0, 1, or more. Those are the three options, 0, 1, or more. If there are 0 such nodes, you're done immediately. All right, there's no celebrity because the celebrity knows everybody. Everybody knows the celebrity, but the celebrity doesn't know anybody. And so these two nodes would both have to know someone that also doesn't know either of them. If there's no such person, then there's no celebrity. Done. The second criteria, if there's only one of these nodes, then that has to be the celebrity. So you can verify it by checking, does this node know everybody, or does everyone know this? Does this node not know everybody, and everybody knows that node, right? You can just check that, right? That's one more routine. That's the 3 times n. That'll tell you whether or not that's a celebrity or not. But now, if you have more than one of these nodes, where these two know these nodes, but these nodes don't know them, the tricky thing there is one of those has to be the celebrity. So I'm not sure. They're saying there's only one celebrity though. But you could have, if it exists. Could you have what I would do is you're going to test you have your set of celebrity nodes to test from. To test that that's the celebrity node, I would actually test against the other celebrity nodes, possible celebrity nodes first. So as you do that, you would eliminate this node or not. And for each of those nodes that you tested against, those don't need to test against it. Basically, there's got to be a node that celebrity node knows that the other two know. They actually should end up forming kind of a clique, because of A and B, they know a bunch of nodes that don't know them. Each of those nodes, there should be a node within that set that they all know, but don't know them. Right, the celebrity node. And the way you would verify that is, really you could just pick one of the nodes and just check within that set. There should be one node that this node knows and it doesn't know. The celebrity doesn't know anybody, though. That's important. So these set of nodes that you can everyone knows the celebrity though, so within that set of nodes that you found, you could just test them one by one to see who knows, whichever node you think is the celebrity. You say, okay, test it against this other node. This other node should know the celebrity, and the celebrity doesn't know them. If this is true for all the other nodes, that's probably the celebrity node. Or that has to be the celebrity node. If this celebrity node, if the other node knows anybody, or knows the celebrity node, if this other node knows anyone, that's not the celebrity node. Now, like I said, it's possible that the celebrity doesn't exist, but obviously if there's nothing in this set in the first place, then immediately we know that the celebrity doesn't exist. But it's still possible that this potential celebrity set doesn't have a celebrity in it. Basically, they would all know somebody. But you can eliminate nodes from that set just by checking to see, does A know B, does B know A? Depending on who knows who, you can figure you can eliminate one or the other. So if you think this is the celebrity and it knows someone, then it's not the celebrity. This other node, if it knows the other person back, then it's not the celebrity. If they don't know each other, so if A knows B, eliminate A. If B knows A, eliminate B. If A doesn't know B, that's something a celebrity would do. And but one of them has to know each other. If one is the celebrity and one is not, if one is the celebrity, then the other one will know it. Will know the celebrity. If neither of them are celebrities though, then they will both know someone. Oh, actually, I think that's the simple. if you look in the celebrity set, you just take a random node, and you run the same routine against all the other nodes in the celebrity set. There should be a node in there that this node also knows, and that's got to be the celebrity. Or either doesn't know any of the other ones, in which case you can extend this check to all the other possible nodes in the list. Or by the way, I'm trying to okay, actually we should be fine. 3 times n. This is really tricky. This is really tricky. So actually we can still use, there's only a limit on how many times we can call knows. We can still use things like a set in order to keep track of which nodes we've eliminated, if that makes sense. Very interesting problem. Basically, I want to say that we build that celebrity set, and now we pick a node, and we check to see oh man, I'm trying to figure this out. I want to say you find a node that A knows, and then you have B. A knows B. Find a node that B knows. We have the set of nodes that A knows, and A knows B. And now you want us the set of nodes that B knows. Alright, so there's some C that B knows. So you got the set of what A knows, the set that B knows. And we want to know that A knows B because if A doesn't know anybody, I guess we want to check if somebody knows A. Everybody's got to know A, right? Well, oh man, I don't know. That's kind of a hard question because you know, you have situations where, you know, a bunch of nodes that doesn't know anybody, but not everybody knows them. They're not celebrities, they're just nodes that don't know anybody. You have a whole boatload of those. You don't want nodes that don't know anybody. Yeah, actually, let's take one of the worst case scenarios where nobody knows anybody. No, but everybody knows the celebrity, so if they don't know anybody, that means that they're the celebrity. Right? Because everybody, or there is no celebrity. Oh, wait a minute. Uh-oh. They're either the celebrity, or there is no celebrity. There's no choice, because if there is a celebrity, then somebody knows them. And if there is a celebrity, then this person knows that celebrity. That was a really interesting question. This is fun kind of logical conundrum to think about. It's going to take me a while to think it through, though. Let's say, where are we at here? This is, how many minutes? 30 minutes in already? Yeah, so if there's a celebrity, this node will know that celebrity. If there's a celebrity and this node is the celebrity, then nobody will know that node. If there's a celebrity, if there's now, I guess there's four cases, right? There's sort of four cases. There's a celebrity, there's not a celebrity. There's a celebrity and this node doesn't know anybody. There's not a celebrity and this node doesn't know anybody. Okay, there's two cases. So we suppose that this node doesn't know anybody. If there's a celebrity, then that node needs to be the celebrity. If there's not a celebrity, then there's got to be, if there's not a celebrity, then there's got to be basically, oh no, I don't know. Okay, let's do it this way. If this node doesn't know anybody, how do we know, how do we find the celebrity from there? Can we determine if there is a celebrity or not from that? If this node doesn't know anybody, if there's a celebrity, it means that it's it. Or it would know someone. So if there's a celebrity, it's got to be that one. Now if there's no celebrity, then what we can do is we can pick another node and just test to see if it knows this node. That'll tell you whether or not it's a celebrity. Because if there's a celebrity, this other node will know the celebrity. And it's got to be that one. If this other node doesn't know it, then there can't be a celebrity. Is that right? No, the celebrity could be, no, doesn't know. Oh, it's so confusing. Because you could have nodes that don't know anybody, and you could have nodes that do know everybody. But the difference is the celebrity has both of those conditions are true. You could have nodes that have some mix of those conditions. Like you could actually have a node that doesn't know anybody and is not the celebrity. Right, in order to verify whether that node is a celebrity, to test, does everyone know that node? And there you go, done, it's the celebrity. Man, that's a hard thing to think about. It's a challenging question. This is a challenging question, to say the least. To say the least. I'm trying to do this without using too many calls, right? I'm trying to deal with a situation where nobody knows this node. Or this node doesn't know anybody. Alright, because I'm thinking, oh, okay, we'll pick a node and we'll figure out who it knows. I'll pick another node and figure out who it knows and take the intersection of those sets. Now there's a few possibilities, right? Everybody knows the celebrity. There's actually a few different options. You got A, B, and C, and they're all different nodes. You can have A is the celebrity, B is the celebrity, C is the celebrity, none of them are the celebrity, celebrity doesn't even exist. You got all these different cases. If A is the celebrity, then B would know A. But A wouldn't know B. And A wouldn't know anybody. And you gotta have to verify if A is the celebrity or not. Same thing with B. B wouldn't know anybody. A wouldn't know B. And you gotta verify that B is the celebrity. Right, in those cases, the set of intersections is empty. Right, because A doesn't know anybody, B doesn't know anybody, or B doesn't know anybody. So forget about that case for a moment. Now, if A and B both don't know anyone, or they don't know anyone that overlaps, then there's no celebrity. So you could figure out whether or not there's a celebrity very quickly between A and B, just if there's no overlap of any kind, or they don't know each other. They don't know each other and there's no overlap. Then there's no celebrity, right? Because the celebrity, everybody would know the celebrity. So both A and B should know that celebrity. Alright, so taking this set for A, taking this set for B, two random points, you can get us a lot of information. You can figure out whether or not a celebrity exists. And then now, the tricky thing is, if they're not pointing to each other, they're pointing to this third node. Now, they could be pointing to a whole bunch of nodes that they both know. Question is, does everyone else point to that node, and does that node not know everybody else? That's the question. I don't think I can do this in 3 times n time. I don't think so. Let me go lay down for a minute here. This is kind of a hard question. Because I'm thinking, because even if you check to see, Actually, we're gonna figure out if we're actually with these. We're gonna figure out not only do they know, or if they don't know. A knows B and B doesn't know A, or yeah, A knows B and A doesn't know B. We're actually gonna get the whole gambit of which nodes A knows and which nodes A doesn't. We're gonna learn all that in one shot, right? All right, so we do that. Find out every node that A doesn't know and find out every node that A does know. Now, in the matrix, what does the celebrity look like? The celebrity has, everyone knows him, which means there's an A on the left side, A to Z on the left side, and on the right side A to Z from top, the top from left to right A to Z, and then on the left side from top to bottom A to Z, we'll say, right? The nodes are represented by letters. And A knows B, A on the left side, B on the right side. That gives you a 1 or a 0. So the celebrity column or row, let's say celebrity is Q, or C, we'll call it C. So C is the celebrity. Everybody knows the celebrity, which means that the column for C is 1. So A knows C is 1, B knows C is 1. So there's a column that's filled. However, the row for C, so C knows A, 0. C knows B, 0. The row for C is all zeros. So that's the celebrity. And they were saying there's either no celebrity or there's only one celebrity. Those are our options, right? That's what they're telling us about the problem. So the row is all zeros, but the column is all ones, and obviously C knows C is always true. So it's everyone that's not C. C doesn't know any of them. So it's pretty interesting. We're looking for this kind of a cross in the matrix, and we're saying somehow there's a way to identify this in a few passes, in a few checks. We can find out. Let's see. How would we find a row full of zeros and a corresponding column full of ones? So obviously, as you saw earlier, we just went ahead and excuse me. Basically counted every column and every row, right? How many ones there were, and we said the row and column pair, right? For particular index on the row, index on the row, index on the column, you have to have 1 in your or 0, right? Excluding the diagonals. We exclude the diagonals in that check. You have to have 0 outbound and n-1 inbound. Basically the column has n-1 and the row has 0. And that's what we did. That was our way we evaluated. That was a pretty expensive way to do it, but brute force. Very directly identify which row has that, which index is the celebrity. But there's got to be a way to be more efficient, so now what's interesting about this graph is it's not symmetric, it's directed, so there's no symmetry to take advantage of. There's no obvious symmetry to take advantage of. The only real symmetry I guess you could take advantage of is that the question that we're trying to answer is sort of, if you inverted the graph, is in some sense the same question. There's like symmetry involved where it's like find the column with all the ones and find the row with all the zeros, and you could sort of and it's all the same nodes, the same sort of indices. So it's kind of interesting. There's like a certain symmetry or mirror aspect to this question I think makes it interesting, more interesting. So what do we do? How do we solve this? Well, now another thing that's kind of interesting is, my thinking is like, well, you can only uncover rows and columns at a time. However, that's not true. You can actually use this nose routine any way you want. You could check. I'm gonna get under the covers because I'm getting cold. You could check if you wanted to, just randomly different spots to try to uncover this, row of zeros and column of ones. Now, obviously, if you run across two rows of nodes, then you'll hit that column. That column will be a 1 somewhere across. However, you may also hit other things that approximate a column but are not actually a column, sort of streaks of ones, which is kind of the problem that I was describing before. And I guess each of those ones that you run across, those columns, those other columns, other possible nodes, you would want to check that I guess first off, you want to make sure that those indices, I gotta think about it, those indices that so A knows, let's say X, and B knows X, and A knows Y, and B knows Y. So possibly X or Y is the celebrity, right? And there could be a whole bunch of these, right? The whole boatload of these nodes that they both know. Ideally, what you'd want to do is figure out I guess you'd want to know, does Y know any of these other nodes that you've uncovered? I'm wondering if I could think of just n algorithm that would work. And then I wonder if I can shave down the algorithm so that it's always at most 3 times n calls to no's. Optimize it a little bit. Maybe that's the idea. Something to think about. Something to think about. Something to ponder. Falling asleep over here. Sorry, I'm falling asleep. Oh boy. Just thinking here. Let's see if we can solve this. So I already have a naive approach that's quadratic. Let's see if we can find a naive approach that's like at least linear, right? So if we check a row, find out what A knows, who A knows, or who knows A would be or X. We'll say who knows X or who X knows. One or the other is going to give you the column or the row. And more likely than not, it'll be a mixed bag, you know. Let's say if we found a column, we can randomly find a row, and those will intersect. And that, I guess, would be interesting. However, I don't know how valuable that would be, or that should be, ought to be, will be. Sorry, man, I'm like, just thinking about painful memories, I guess. Got a lot of painful memories. There's easy solutions, stop thinking about them. You know, it's like, why bother? Why even, there's nothing, there's nothing to think about. Yeah, that's a pretty simple solution there. Anyway, so what I was thinking, what I was saying was, forgot what I was saying. So I have a lot of painful memories, a lot of painful thoughts. You know, it's not just the memories, it's the thoughts that I have that accompany those memories. A lot of really evil thoughts, I guess. Evil, yeah, let's just say evil. Let's go with that. A lot of evil thoughts. Anyway, it's nothing to, there's nothing to think about, you know. There's nothing there. Sorry, just give me a minute. Just give me a minute. I don't know, my mind tends to wander sometimes, and I guess some thoughts are hard for me to move away from, to think about something else. Not that I get trapped, but I get kind of stuck thinking about it. Tempted to think about it more than I should. But anyway, with this problem, I'm kind of hung up on this problem. You know, I don't see any solution at all. I mean, nothing that's more efficient than what I already described. I mean, because you can. I said nothing comes to me at the moment. You can like take two rows, and then you can identify some potential columns. You know, but you really could have like just everybody knows everybody kind of a situation where there's just a whole boatload of these of these. You know, actually, hold on a second. Wait. I'm wondering if there is some symmetry in this matrix that I'm missing out on. If A knows B, that means the row for A and that column B is a 1. I think that's it. That's it. Never mind. No, it's not symmetric. No, there's no symmetry. I'm wondering if no, there's not. Anyway, so you find these rows, you find these columns that A and B, X and Y, they know a bunch of, and there's some intersection, right? There's some potentials. Could be celebrities. These values. I guess the next thing to do would be to check one of these to see another row to see, does this node see, the thing is, you don't necessarily need to go through another row, I guess. Like, I want to say something like, of the nodes that A knows, one of those is a celebrity, right? And I mean, you could have done it the other way around too. You could have looked at a column in all the who knows that particular node, and came to a similar conclusion, right? Mixed bag. Some people know him, some people don't. Excuse me. Man, that's kind of hard too. Like, if you're only going to use, if you're only going to use 3 times n calls to knows, then really you've got to have one, you only can do, some variation of 3 columns or rows, right? It's some, 2 rows in a column, or 2 columns in a row, or something like that. You really don't have a lot of choices. Oh, you know what you could do? Okay, I think I got it. So you start with a row, and you say, check each node to see if that node knows this node or not, right? And, or rather, no. Other way around. Take this node and take a look at all the nodes that it knows. So it's going to take every node. So 0, it doesn't know that node. 0 doesn't know that node. But then it sees a node that it knows. You see a node that it knows. Okay. Now you take another node, random node, and you check, does that node know this node? If it's a celebrity, it should. And then you start going through all of the nodes to check to see if the nodes know that node. And you should, if it's a celebrity, they all will. And then you just verify that it's a celebrity by checking to see that it doesn't have any that it doesn't know anybody. Now the thing you got to be careful about here is there can only be one celebrity, because by definition the celebrity knows everybody and doesn't know and no one knows, and it doesn't know. No, everyone knows the celebrity doesn't know anybody. If there's 2 celebrities, they would know, one would know the other celebrity, right? They would know each other, and they could not be celebrities. So if there's a celebrity, everybody will know him, and he won't know anybody. And probably once you've gotten that everyone knows him. Now here's a tricky thing. If you find someone that everybody knows him, does that guarantee that he's the celebrity? Not necessarily, because you could have another node and everyone knows him, except he knows somebody else. Which is interesting. Yeah, that's tricky. That's a tricky thing. That's tricky. Which is kind of what I'm stuck on. Is that it costs a lot of API calls to check, to verify whether a node is a celebrity or not. Is there some node that the celebrity node knows? That's pretty awkward. In fact, you could have everybody knows everybody else, but there's only one node that doesn't know anybody else. Everybody knows everybody else except for one node. So that means that there's ones everywhere in the, in the matrix, except for one row. It's all zeros. Now, that would be interesting, wouldn't it? And what you would do in that case is you would have one node, you check to see if it, knows anyone. It knows one, the first node it looks at, says it knows that node. Then you'd say, okay, does everyone know that node? And you find out that everyone does. Except one node that doesn't. That's not the celebrity node. Turns out that one node that doesn't know them must be the celebrity then, so you can verify that. And you check and you say, okay, does every node not know it? True. Does it know every node? True. Done. Actually, in that case, it is 3 times n. It's n minus, it's one call to find that node. Right? A knows it. Then n minus 1 more calls to show that there's one node that doesn't know it, or n minus 2 more calls. That's n minus 1 calls. Then n minus 2 calls to find out that nobody knows that node, or that node doesn't know anybody. So that's n minus 1 plus n minus 2. And then finally, another n minus 1 calls to find out that that node, that everyone knows that node. And that would work. So I guess what you're looking for is you're really looking for a node that 2 nodes don't know it, 2 nodes know that node, and this node doesn't know those 2 nodes. That might be more of what you're trying to do. That'll give you, okay, I think so. Okay, so you do two rows, 2 random nodes, 2 rows, and you get these 2 nodes know some node, or they both don't know a certain node, right? Or rather, no. They both know a certain node. There's a whole bunch of nodes that they know, that they both know. So there's a whole bunch of nodes that they both know. Okay. A whole bunch of nodes that they both know. And then, so when that happens, you check also, do both of those nodes, or that node that they both know, does that node not know them? Right? That node doesn't know them. And it's a good sign if it doesn't. If that node, well, we could do if everyone checks that. You could check to see does everyone know that node. I don't know, man. It's hard. It's hard to say because, like, checking the whole property for a node, you have to check that every node knows it and then it doesn't know any node. It's very challenging, we'll say. Yeah. Like, I don't know if you can do that in just like one or two. Like, I don't know. I don't know. Ugh. Struggling here. Struggling. Yeah, forgive me my thoughts. Forgive me, my thoughts are starting to wander all over the place. Oh boy. Oh, not fun to think about these things. But anyway, back to this question. Let me think for some more. Let me think some more. Oh man. Okay. All right. This problem isn't as hard as I thought. Okay. So you have this node, and you check. Okay. Does it know? Notice. So there's some node A. Does it know B? If it knows B, B might be a celebrity. If it doesn't know B, A might be a celebrity. But if A knows B, then A is not a celebrity. Eliminate A. If A doesn't know B, A could be a celebrity. If A doesn't know B, check does B know A? Right, so A to B, B to A. If A knows B, then, okay, that's what we gotta do. What we gotta do is we gotta eliminate the nodes that couldn't be celebrities. That's what we want to do. And I think I do actually think we can do it in basically 2 operations per node to eliminate. So yes, I think we can do this in 3 times n. I don't know why it just hit me now, but we're gonna do a process of elimination. We pick a node, pick node 1. Does it know 2? If it does, that eliminates 1. If it doesn't, check this 2 know 1. If they don't know each other, that doesn't help us very much. If A doesn't know B and B doesn't know A, I don't know if that helps us very much. Yeah, there's 3 possibilities. A knows B, A doesn't know. Four possibilities. They know A knows B, A doesn't, and B knows A. They know each other. One knows the other doesn't, and then they don't know each other. Two of those cases, one of these nodes gets eliminated. Well, actually, 3 of those 4 cases, one of these nodes gets eliminated, right? If you're not a celebrity if you know somebody, right? That's what it comes down to. Oh. I'm sorry. No. Yeah. No. Because if A knows B, A's not the celebrity. If B knows A, B's not the celebrity. If A doesn't know B, then B's not the celebrity. Because if B's the celebrity, A knows B. Oh, okay, all right. This is not bad at all. So yeah. So you check both. Does A know B? Does B know A? All four situations, one of these nodes gets eliminated. A knows B. A's not the celebrity. A doesn't know B. B's not the celebrity. B knows A. Or actually, wait a second. If A knows B, A's not the celebrity. If A doesn't know B, then B's not the celebrity. So actually, you can eliminate nodes pretty quickly. So actually, no, I'm sorry. So you really only need n minus 1 calls to eliminate n minus 1 nodes, and then you just have to verify that that node is indeed the celebrity in 2 times n calls, or 2 times n minus 1 calls. Yeah, no, this is actually very doable. I don't know why I'm struggling so much with this, but so, right, okay, so all right, so you've got a set of nodes, got your set of nodes, pick one out, and you say, okay, pick two nodes, pick, A and B, 2 nodes, and you perform the check. One of these nodes gets eliminated, right? Must be. If A knows B, that means A can't be the celebrity. If A doesn't know B, that means B can't be the celebrity. So now you remove that from the set, and you perform another check. Do it again, right? To get down to 1 node, and then now on that node, yeah, okay. Brother, why was I struggling so much with this? Why was this so hard? I don't know. Freaking, if you've ever seen that cartoon Jimmy Neutron, where's the freaking brain blast? That's how I feel right now. I just had a freaking brain blast. Brother. I feel so silly now, but, well, okay. I guess that's that. Alright, you ready for this? Here we go. And this is going to be, iota. On a list. Yeah, we can call this S. Why not? Alright, what does this look like? from the algorithm library, probably numeric. What is this? Cannot assign to return value because function operator returns a const value. Oh, I guess it doesn't work. I guess can't do that. Oh. Huh. Anyway. I don't know. I think I did something weird. Zero, 1, 2. I think I wanna. I wonder. I don't know if this makes sense. No. Also, I really want a hash set, not a regular set. Just by the way. Yeah, the problem with iota here is yeah, I think we did it this way. I'll explain. So you need like a size, basically, in order for this to make sense. Yeah, okay. Basically, you need like a size, you need a beginning and ending iterator. And you don't really have a beginning and an end when you're dealing with just sets. I mean, they have a beginning and an end, but they're not the iota iterator doesn't really make a lot of sense. Operation doesn't really make a lot of sense on those containers. Anyway, so what we want to do now is basically while s.size is greater than 1 or not s.empty, we're going to say really just some random value. Int. It's actually yeah, size is greater than or equal to 2. We want to say A is going to be start begin, and B is start begin plus 1. Now, what we want to do Oh man. Whew. Just thinking what I'm gonna do for the test cases. I don't know. I'll just leave it. So, just leave it for now. Just write the code. Because there's only one node in. There's only one node. Or there's 0 nodes. I don't know what that should return. That's why I'm thinking about these test cases. I could say there's just, it's empty, right? What do we get? What is this 110 supposed to be? One 110. I'm so confused. Graph ij equals 1. 0, 1, 2. Zeros. Oh, well, that makes sense now. Okay, yeah, I get it. This is the matrix. So 0, 0, 1 means 0 knows. Yeah. So all the diagonal should be 1, but 0, 1, 0, 1 being a 1 means 0 knows 1. Oh, I see. Oh, that's interesting. Okay. So let's say there's no nodes, and let's say there's one node. 0, 0, 1, really, it would be, what does that look like? Size is at least 2. Oh, okay, got it, sweet. Alright, so the size is always at least 2, so you don't have to worry about that test case. So in this case, we're going to say if knows of A and B, if A knows B, now let's say bool, check, right? If check, so here we go. If A knows B, B is not a celebrity. S dot race B, or S dot remove, say erase, yeah. Erase B. If A knows B, if A knows B, A is not a celebrity. If A doesn't know B, A doesn't know B, B is not a celebrity. So in either case, we eliminate an element while we have greater than or equal to 2. And then now we got to just check, is that last value, so let's say int C, it's going to be S dot begin, dereferenced. And we say for int I equals 0, I is less than n. We're going to say int outbound, inbound. We'll say if I is not equal to C, right? You're going to say inbound is plus equals knows of, so C, something like this. It's going to be outbound, inbound, So we say everything that's not I, we're going to check. So we want to say the celebrity. So everybody knows the inbound. Everybody knows C, right? And the outbound is basically not that. Does C know everybody else? And really, yeah, we could just do, yeah, we don't have to do negation. So the outbound is C knows I, inbound is I knows C. And you want to say, basically, inbound equals N minus 1, outbound equals 0. You're going to return C, otherwise return -1. Something like this. That compiles. Time limit exceeded. Nice. Nice. Okay. What? Okay. What is going on? What is going on? Two, 1, 0. Really? What isn't this? What happened? How come? What's going on, man? Oh. No. That might be why. I don't know, actually. What does that look like? No. No, that's fine. I give him no. Why? Oh, of course. I'm sorry. That's what happens when you mess around with, no kidding. Oh, okay, interesting. That's what happens when you mess around with, That's what happens when you mess around with too many containers and their different names. Some weird stuff. There we go. Okay. Sweet. Yeah, you started naming the iterators incorrectly. Yeah, basically you just set an iterator to some element, advance it to some other element, check if they know each other. If they do, remove one. If they don't, remove the other one. And then you'll narrow that down to one element. And then you should be good to go from there. Alright, how do we do? Should we go for other test cases? Oh no, those are invalid. Alright. I don't know. Let's go for it. Let's go for it. See how we do. Oh, hey, we got there. Sweet. Nice, man. Hey. You know, I wasn't expecting something so simple to work. But it did. Not bad. How did, huh. Hold on a second. How did... So way to do this is faster than this? I mean, you can get rid of these. I should give you the same answer. Not much faster though. So the inbound, the outbound, instead of adding, you or. And the inbound, you and. So all the inbound's true and all the outbound is false. Oh, wait a second. Except for one. Yeah, we just do. I think you gotta do it that way. Not sure that's much better. Doesn't really improve the time very much. I want to try to do this without creating this set, you know? Oh, I got it. I don't need a set. I got it. I know what to do. I know what to do. So if A knows B, A is not the celebrity. And vice versa, if A doesn't know B, then B is not the celebrity. You swap that value at the back and pop it off. Swap that bad boy off the back and pop it off. You can do all that with a vector. There you go. Uh-huh. Now you try something like this. Give that a shot. See how that goes. Alright, still not very fast. Still slow. Come on, man. Really? Really? I feel like that's so much more clever. So much smarter. I don't know, man. It's best I gotta think. How did they get faster than this? Let's go to the discussion. Constant space? Really? What? What? Oh, that's probably why it's so much slower. Some people were able to do it with constant space. Oh, that's upsetting. Well, that's frustrating. I thought it was so smart. I figured out a way to do this with oh man. With this, linear, small number of these calls. In that case, how do we figure out how to not use extra space? Okay, I don't know. I gotta think about that. Oh, use 2 pointers, okay. Oh, I see. Oh, I have an idea. Okay, alright, I got it. You consider... Okay, I think I got it. I understand. Okay. Something like this. I don't know, we'll just do while true. Start with while true, and we'll figure out the condition later. So if A knows B, get rid of A. Erase B. So the way we erase A is we increment A. And if A is equal to B, increment B as well. Right? So move the pointer. So we move the pointer from A. So we never go backwards basically. And move B. Always erase B, increment B. So we're always going to move either A or B. And if A bumps into B, obviously we're going to move B. We could still consider A and B. we're still going to consider those. But the thing is, when you move A, here's the thing. We should actually do it the other way around. Let's do it this way. A and B is going to be N, right? Or N minus 1, right? It's going to be 0 to N minus 1, yeah. So A knows B, increment A. Erase B, you decrement B, right? And you're going to keep going until while A is not equal to B. Or well, A is less than B, really. I think that's what you do. Do it this way. Now what happens is C be set equal to A, or they should be equal to each other. Eventually, they're going to collide and point to the same thing. And then you can just use A instead of C. Something like this. Hopefully it makes sense. That works. Okay. Let's see how we do. Alright, let's go for a harder. Oh, hey, there we go. Wait, but how come it's the same speed? What? Come on, really? What? I got rid of so many things. What do you mean? Come on, man. Come on, man. Are we still connected to the internet? Are we dropping frames? What's going on? What's going on? Why does it feel like it's going really slow? Like something's wrong. Alright, it's a little faster, but it's still slow. It uses way less memory, but... Come on, man. How do I make this faster? How do I make this faster? Huh. Man. How am I supposed to make this faster? I don't know. I don't know. I don't need to make it much faster. I don't think it's gonna make it much faster. No, slowed it down. So I actually slowed it down. Shoot. Shoot. I don't know, man. I don't know, man. Well, oh, ouch. Whoops. All right, that's a little faster. That's a bit faster. I really don't know, man. Could not tell you. I could not tell you. How about this? If it's true, it'll increment A, and it won't touch B. If it's a 1, increment. If it's a 0, it won't touch A, but it'll decrement B. How about that? Let's give that a shot. How does that look like? Let's go for it. Not much faster. Not much faster. How am I supposed to speed this up, man? I'm not gaining speed doing these things here. I'm questioning things. I'm questioning things. Some things just don't seem right. I don't know, man. I don't know, man. How am I supposed to do this here? What in the Sam Hill? I wonder if we just say a Boolean. And we do a similar thing anyway. This works anyway. It's a little faster. Not much faster. I think for readability's sake, we'll do it this way. Yeah, I think it's it's better to be able to read it. How to do it? How to do it? I'm only 40%, huh? Which one's faster? So this is at least linear time, constant extra space, and it uses only 3 times N calls to the nose API. Man, I don't know, but I sure like that hat. I don't know, but I sure like that hat. Brother, I can't believe it. How did we get it so fast? How did we get it so fast? You get this so fast, man. Boom, 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 boom. Whoa. HB Sophia. 2 hours to finally figure it out. Moore's voting algorithm of finding the majority element in the first pass. Person who is known by most other people stands out. Then we check whether everyone knows him, and he knows no one in the second pass. Huh. Well, that's interesting. So, if I knows this candidate, if I doesn't know this candidate, set candidate to I. So some people are saying it's like a comparator. It's like saying, you know, if, so there's like A and B, compare A and B. So like A is greater than, or A is less than B is to say that A is greater than or equal to B. Set the new candidate to I. So it's actually like, yeah, like the max, the largest element is sort of what people are saying. It's sort of the element that I guess everybody knows. Or it's everybody doesn't know, really. So if I doesn't know this candidate, I can update to I. So that really should be the, that really ought to be the, celebrity, potential celebrity. And then you just check for each other node, skip the candidate, and you say, oh, terminate early. Oh, I didn't think to do that. Oh, that's a lot better than what I did. Alright, so you can do this one. Oh, I see. Yeah, it's a lot better. So, alright, we can just continue to keep the logic simple. So if knows IA, or not knows AI, turn -1. It's basically what was done. Okay, that is faster. That's a lot faster. And also the other routine is faster too, instead of using 2 pointers. So if I knows A, it's actually the other way around. If I doesn't know A, that means A can't be the celebrity. If A knows I, same thing. A can't be the celebrity. Wrong. Nice. What? Excuse me. Oh. That might have something to do with it. Go for it. Okay, that's a lot faster. Yeah, that's a lot better. I still had constant time and, linear time, constant space, and the bounds on how many times we call knows, but I just didn't have that optimization for this routine. Terminate early by ruling out sooner, and then if you don't rule it out, then return it. Yeah, I could have restructured my logic a little bit. And then here, instead of using 2 pointers moving from side to side, you can actually just do, we'll call it A. Let me say if basically checking against each candidate. If you're looking for the one that nobody knows, right? So if I knows A, if I doesn't know A, it's likely that A is not the. If I doesn't know A, that means A can't be the celebrity. So update A to I. That's another way of doing this. Should get the same result. That should be a little bit faster as well. It's a lot faster. Praise God. Praise God. I wonder if I can actually do it the other way around. Now, if A knows I, does it still work? Might. Could try it. It does. Look at that. Yeah, I thought that might be the case. Yeah, they should be. Those are logically equivalent. A knowing I, and I not knowing A, and I knowing A negated. If that makes sense. It's actually not that they're logically equivalent. It's that this property is like invertible, basically. If A knows I, then it's likely that I would be the celebrity, and A can't be the celebrity at that point. It's more likely that I would be the celebrity. Pretty interesting. Yeah, 2 passes for that. And then you can do this. We could also throw this in here. It's a little confusing to do it this way, but technically it gets rid of one branch, which might make it a little bit faster. Not much faster. Alright, now we're faster than 80% of the solutions, but we're still much too slow. How do we go faster, man? I don't know. That's beyond me. That's all I got. This is probably it. It's for me as far as like solving this problem, making it faster. It's probably about as fast as I can go. Looks like the continue statement was actually better. Not much though. Excuse me. Oh, I was doing it when we get that top 10%, man. Just can't get in there. Also the memory too. We're using too many variables. Gotta reuse our int I. I guess so. Yeah, does that reduce the memory slightly? Maybe it does. That'd be pretty funny. That would be kind of funny. How about this? Does that still work? It shouldn't be faster, but it's... Nope, same amount of memory. Same amount of memory. Alright, it's time for bed. Alright. Oh, for some reason that went faster. Who knows why? Alright, we'll go with that. That's pretty good. For some reason this used less memory and went faster. Who knows why? I don't know. I couldn't tell you. But, not bad. Let me go ahead and end the stream here then. Yeah, maybe a little bit of cheating, like a little bit, tiny bit. Not really. I mean, kind of. I used instead of using the 2-pointers, that routine that does comparisons. It's pretty interesting, that routine. But yeah, it's basically like a, oh, we're dropping frames, look at that. No kidding. It's basically like a, it's kind of like a maximum or minimum search for a value. And finally, we want to know and then obviously the last routine is like just a brute force check. Pretty neat, pretty clever. Pretty grateful for this solution. It says we're not. Are we? Oh, okay, never mind. I was gonna say it doesn't say we're recording. The reason we're not recording is because buffering. Oh no. All right, let me end the stream here. Thank you all for watching. Appreciate it. Talk to you soon. If you like the video, don't forget to like and subscribe. And talk to you soon. What am I missing here? I don't know. No, nothing. Nothing to say. Just that was an interesting problem that took me a long time. It's yeah, pretty interesting. So I don't think I really have anything else to say. Apparently we're buffering too, so I'm sorry for that. Let me go now though. Alright. Have a good night. Talk to you soon.